Okay, now that you have heard everything about UI and NetVoice, I'm gonna give you probably the nosebleed, because the true name of this presentation is not arming yourself with NS8, but it's turbo building images and more. So, without further ado, let's dive right where I need to go, which is I love to self-host applications, and I got a reasonable amount of infrastructure inside my house, which is a Raspberry Pi, and that's it. I don't have anything else. So 32 gigs of memory and 4 gigs of RAM, and this little ARM core. And as you can imagine, why did you choose a Raspberry? And I'll give you some of the reason. Because it's very cheap. It was about 50 bucks. Now it's more than 120. Don't ask me why. It has a very low power consumption. It's about 15 watts tops. It's a small form factor. Basically, this Raspberry sits behind my printer in a corner of my house. Will never be touched again. The chain of supply is not bad, and this is an asterisk because it's not very cheap anymore, and you can't find it very well. And it is my only hardware in the house. I don't have anything else spared to have it sit inside my house, so I'm gonna use this. Okay, then I got itched in the brain. We got a message on the community, which was this. I'm not sure if this was even supported, and I say it on Raspberry Pi 4. Before this message, I run everything inside containers in a Docker Swarm environment, so it's multi and something. But seeing this message made me think, okay, let's start working on it. How hard could it be? The answer was not that hard, but we need to make some changes. The first thing was replacing the builder of NS8. We use Builder for the builds. However, I needed something that handles well multi-architecture and allows a feature that is cross-compiling the different images, which is why I replaced it with Docker, which is a tool that got very, very popular in the last even month due to the build kit image. So basically every image that you build, it's inside an image itself, which makes very faster, ships everywhere because it's an image, so why don't you have it? But I'm gonna tell you why I replaced the builder. What are the main reasons? One is the GitHub runners, and I'm gonna show you why in a minute. And the second is feature availability. The first one is GitHub runners. This is because GitHub runners don't run the latest software. Actually, they run Podman version 3.4.4, which is very old, and with it they run build out 1.23.1. Why do you think? Because it's based on Ubuntu 22, and this is why they are stuck with these versions. They are missing some features with these versions. They are stable, fine, but in the latest even year, Build and Podman grow so much, but we don't have the advantage here. I'm not gonna use my machine to build every image. It's gonna take a decade, probably. So one feature, what are the features missing? One is the support for cache. The latest version of Buildan and Podman does have the cache support. However, they are not handled very well, because for every layer that you create a copy of the previous, which means if the image starts at 1 gigabyte and you add a 2 megabyte files, the second layer will be 1 gigabyte plus the 2 megabyte files. Not bearable on the long term. One is the proper multi-layer build, which at the moment the version on GitHub doesn't support well and builds layer that is not supposed to build. Hence, a lot of time wasted in the air. The last thing is the automatic manifest generation. This is a turbo nerd term, Because if you build images for Docker and you build two images, one for AMD and one for ARM, you need to have a layer that connects them, so it's always one image. In Podman, this doesn't happen right, or well, it doesn't happen automatically. You have to manually create it and distribute it. So I started because the first step that I need to do is to pass from the script that we have that builds the images in the core to a Docker file, which is the format that Docker supports best, or the only format that it supports. So I'm gonna highlight a few lines just to make sure you follow me. So this is where we define the first container, and this is where, I don't know, we say, hey, the volume of the data that this container, which is in cases where this is saves, is data. The GMD to launch is this, and can think, oh no, I can move it. Okay, you will see a command below. Okay, so you will see we're under the servers of this data is G, Redis, and whatever. And I moved it to this. It's a bit cleaner, however, it does the same job in the previous one. We use the same image, and we say the same volume, and we say the same command. Nothing changes here. I just transcribe from one to the other. So the first thing that we need to do is to do this process for every image we could build. So core, we got Redis, we got Rustic, we got rsync. So 4 images just for the core. And I'm going to introduce another Turbo Nerd tool because it's Docker Build Kit. I told you at the beginning that this is the tool that even Containerd uses. So Containerd doesn't have a build, it uses this because it's fast, it's cheap, and basically is extensible to whatever what we want to do. BuildKit basically handles multi-arch images, builds manifest, pushes to registry, cache management, and basically you can run everything, even in the cloud if you want to. So this is the workflow of an image. So from BuildKit, which is the build kit, runs core, which builds 3 separate images, that then join into one manifest and pushes the manifest with all the images. And since we are doing cache, since we don't want to rebuild the images every time, we push even into cache. So we got 2 pushes with one build. It must be hard to use this. It is not. It's just a single file. All processes, everything that they show you in that flowchart that happens for every image, it's about one file. The file is about 50 rows, more or less. And if you go to my repo, that I will link later, you can just run this. Let's build all the images. Nothing else to do. At the end, what I did is this. So we pushed, and you can see the repo is the tbile/nsa core, which is basically a fork of what we had. I just replaced the build with new build, and that's the only thing I was needed to do. In fact, I am currently pushing and merging the commits from the upstream, so this is actually up to date since yesterday. Today, I don't think any commit would have been pushed. So, what I did with this change, if you see the repo, not many lines are changed. However, we had an ARM-based build. Not only, we had 3 builds, even for ARM 7 and AMD 64, and we had the cache. Why the cache is so important? Because the builds, not only they build fast, but after the latest rebase, our build took almost 4 minutes, the official NS8 one. This took over 4 minutes, but it built 3 times the images. So if you compare 3 minutes to 4, but it builds 3 times, you can see this is way faster. And that was about it. You can see the project at the QR code, or this is the link. The presentation is even in my GitHub, so if you want to dig in and see what I did line by line, you can see that. Thank you. Oh.
I have a question.
Yeah. I've been taunting him since I did
when the cache comes in, when you put
Okay.
the build image in the cache, but when I put the image out of the cache. In
Okay,
the build
so
process.
basically every cache, GitHub, not the GitHub, the buildx lets you define two parameters in the command line, which is our build from and build to, cache from and cache to. Cache from is where, when I'm building, I'm gonna pull the cache from. Cache to is when I write at the end of the build the cache. One cool thing about this and buildx, they have it on, I think it's beta. You can use GitHub cache registry, which means it's 10 gig free of cache. And I add that to the final process for the build. That's you. Okay, so this is the big file that handles all the builds. Not gonna show that, so I'm gonna say how many platforms are there, and if you can say, I'm gonna, hey, take the cache from GHA. This is telling him, hey, go to GitHub registry cache and pull the cache from it. And this is useful, and this is in this file, because even if you build in your machine and you are logged to GitHub, you can pull the cache from there. Then, when I have the authorization to push into cache, only when I'm on GitHub. So I'm gonna override, actually, this on the workflow, which is here. I'm gonna say, hey, for every, this is every target, so every image that I'm building, dot cache from type GHA. Cache to type GHA. Mode max is just an add-on that allows you to push every layer in the build. So even if something changes in the mid, you can still have some cache.
But this is not expressed in the Docker file.
It's not a Docker file feature, no.
Okay.
You can manually add it. It should be added here, because here you have the permission and authorization to push the registry. This is why this is only here. Docker file is complex, uses a lot of the latest features to cross-compile efficiently, because if you just tell him, hey, go to ARM and build it, it will take like just for one binary of the core, and we have 10 minutes, just for one binary. Because it emulates with QEMU, and it takes a lot of time. I told you it would be a nosebleed.